Okay, so this is going to be the circle theorem proofs. Okay, probably came up a couple of times only, so just but you still should know how to do this. Okay, so it says prove the angle AOC. AOC is this angle. Is twice the angle of ABC, which is basically the circle theorem goes angle at the center is double the angle at circumference. Okay, you got to prove that. Right, let's see. So in these type of question, you make a triangle. So this one, how about we make a triangle here? Oh, come on. Okay. You do not use any circle theorem in your proof. Okay, don't use any circle theorem. So let's say we call this angle x. So ABO is x. Okay, and what's the other one? OBC. OBC we will call it y. Show me. That angle is y. You know that this is your radius. That's your radius. So isosceles triangle. So if that is x, that is x. This will be what then? 180 minus 2x because total angle in triangle. That's a sorry. Start again. That is a radius. That's the radius. So isosceles triangle. If that's y, that's also y. And this angle will be what? 180 minus 2y. Then what about this angle? So you do what that is 360 minus, because total angle around a point is 360 minus, put in a bracket, to be honest it's better, 180 minus 2x, take away 180 minus 2y, open the bracket, 360 minus 180 plus 2x minus 180, okay, plus 2y. 360 minus 180 is 180, take away 180 is 0, that goes away, so it's 2x plus 2y. So this angle is 2x add 2y. And what is this angle is? This angle, so what is it? ABC is, angle ABC is x plus y. What is the angle AOC? 2x plus 2y. You can take the 2 common, x plus y. So it's twice that angle. Okay, since proven. Good. Next one. Show that angle in a semicircle is 90 degrees. So you need to know, show that this is 90 degrees. So what did I say? Always make a triangle here in this course. Here, there you go. Okay. So let's say your angle, should we say, let's call this angle x. Depends. Yeah. Let's call that angle x. So OBC is x. Isosceles triangles, so that's also an x. This is what then? 180 minus 2x. So what about this angle? That angle is what? 180 minus that 180 minus 2 because it's total angle in straight line, isn't it? 180 minus 180, that will be a plus 2x. So that cancels, which gives you 2x. So this angle is 2x. And you know that this is your radius, so that is, and that one is an isosceles triangle. If that's 2x, what about these ones? Those are 180 minus 2x divided by 2 because base angles are the same, which is 90 minus x. So that's a 90 minus x. That's a 90 minus x. And you want to show this angle is 90 degrees. So add it up. 90 minus x, we have plus x, because I'm just adding these two angles up to make this, which will give you cancel is equal to 90 degrees. So what is it? ABC angle is 90 degrees. Simple. Okay, very simple 3-mark questions. Make triangles, say something is x, and then you should be able to do. Okay, in this question you will see you can't use circle theorem. In this question you are allowed to use circle theorem. Okay, good. Points that prove that angle ABD is same as ACD. Okay, ABD is same thing as ACD. Okay, let's see. Now, so you make a triangle out. So you go here to here, here to here. You're allowed to use a circle theorem on this one. Okay, so let's say this angle is x. So let ABD is x. If that is x, what is this? 2x. So AOD angle is 2x. Why? Angle at center is double the angle at circumference. Because you could technically see that, right? Look, there you go. Angle at center is double the angle at circumference. So if that is 2x, what is this? ACD is x. Why? Because angle at center is double the angle at circumference, so this must be x. Therefore, ABD and ACD are equal. Shown. Because ABD is what? ABD is x, ACD is x, both are equal, hence shown. Okay. Prove that ABC and ADC adds to 180. Okay, why not? So what do? Always remember, make a joiner here. You don't need to make a triangle, to be honest, but yeah. So let's say this angle is x. So remember, angle at center is double the angle at circumference. If that is x, what about this? Okay, so this will be x over 2. Okay, actually, you know what? Let's call it 2x because then your numbers will be easier. Okay, so let's call it 2x just so you don't have to divide it into a fraction. Okay, so AOC is let AOC is 2x. So what is ABC is x, because angle at center is double the angle at circumference. So that's x. Then what about this angle? 180 minus 2x, because not 180. How could it be 180? 360 minus 2x, because remember it's a point, and if this is 2x, that's 360 minus 2x. So what about this angle? Remember, angle at center is double the angle at circumference. So what do? 360 minus 2x divided by 2, which is 180 minus x. What is that angle? ADC. 180 minus x. And what they want you to do? ABC. What is ABC is? X. Add ADC. What is ADC was? ADC is 180 minus x. Then if you add them, that cancels. What's the answer? 180. Hence shown. Okay, simple. Now we just got to go prove that BCE is this, is the same thing as BAC. BAC is this angle. Okay, so what do? Make a triangle from here to here. That one. There you go. So you know that OCE, angle OCE, is a tangent, isn't it? OCE is tangent, which makes it 90 degrees. Tangent at a circle is 90. And we're going to say, actually, let BCE is x. So that's x. That's 90. So what is OCB is then? 90 minus x. So remember, this is a radius. That's a radius, isosceles triangle. If that's 90 minus x, what's this then? 90 minus x. So what about this angle? Because in a triangle, what do? 180, take away. What is 90 minus x? 90 minus x, if you add it, is 180 minus 2x. Make sure you put in a bracket. 180 minus 180 plus 2x. Remember, that cancels. That just gives you 2x. So that's 2x. If that is 2x, angle at center is double the angle at circumference. You could tell. Yeah. So what's that? X. CAB is x, because angle at center is double the angle at circumference. So what is BCE was x, equal to BAC was also x. Hence proven. Good.